Okay, so we're in the lab facility now for Quasar's biodigester project. So what are we looking at here?
These are pilot scale digesters. They do almost exactly the same thing as the full scale. It's better to test one of these and have one of these go bad than to have a full-size 550,000, million gallon one go bad. These ones when you're starting the day. The big one takes a month, 2 months to restart. So what we'll do is we'll get a sample in from a feedstock provider, and then we'll test it out in one of these. We'll measure the temperature, the gas production, the methane content, and just about any analysis we need to do on one of these before we put it into this.
Basically, it's a small-scale model so that you can test what's coming in, how much gas that's going to produce, and then you can scale that up to the full size, and then you have a pretty good idea of what to expect based on the results from this. Makes a lot of sense. Very cool. So this is another part of the lab. So what are we doing here?
In here's all the analytical equipment. We'll measure the carbon, the nitrogen content of all of our samples. The higher the carbon, the better. Generally, they're short chain carbons. We have a little bit of trouble digesting long chain, which would be like a paper or cardboard type material. We also measure the acids. That's the machine in the corner there. That'll tell us if certain acids are getting too high. Acids, the higher the acids, the worse it is for our digester. They kill off the bacteria. This machine sitting here measures the gas content. So it'll tell us what percentage of the gas is methane, what percent is nitrogen, oxygen, CO2, the 4 gases we test for. So we'll test, we want about a 60% methane, 40% CO2. If there's any nitrogen or oxygen in the system, we know we've got a leak somewhere. So that's also one of the benefits of that. This machine here costs more than several, it's about $190,000, so it costs more than a house.
Wow.
It's an inductively coupled mass spectrometer. It uses superheated plasma to separate all the elements out, so down to parts per trillion.
Wow.
And that'll tell us if our metals in our effluent going out to farmers' fields are too high, or if the metals in like the wastewater treatment sample coming into our system are too high. And we can also test, what the carbon, the nitrogen, that it's easier to test that on there. We also test for COD and the VFATIC. COD is chemical oxygen demand. That tells us how strong the feedstock sample is. The higher the COD number, the better the feedstock is for our system. Our average COD is about 200,000 right now. And then VFATIC is volatile fatty acids and total inorganic carbons. That just pretty much tells us how much we're feeding in a day, if we're feeding too much or too little. If the number is between 0.2 and 0.6, we're feeding perfect. If the acids are too high, it's like the range is over 0.6, then we know we're feeding too much, and we need to cut back on the feed, get it back to that optimum 0.4.
So is that tested daily then?
Yes, that's set run every day.
That sample has been brought here?
Yep.
And then you can test that, and then you know how to adjust out to the large facility.
Yes, exactly. If it's too low, we know we can feed more. We know we can increase the feed rate, get more energy production.
So it's monitored daily on a 365-day.
Yeah. The other samples like that's run once a week. The ICP-MS is run once a week. And at each facility, the gas is measured as it's being processed. We use that for our pilot scale digesters out there.
So a lot of chemistry, a lot of things going on here. So obviously there's a lot of careers available for students that might be interested in this type of field, and it's a growing field. Exactly. So there's a lot of things that are exciting in the field of bioenergy, it sounds like, and a lot of career potentials that we don't even know about at this point in time, and some growing fields that students need to be aware of. So again, I appreciate you for showing us through the lab today and the process. So we just appreciate Cody and Quasar allowing us to tour their facilities to see those exciting things happening with biofuels and what's going to be fueling our energy needs in the future.